So in today's problem, we are given two array nums1 and nums2 and given n and m as their dimension, and we need to pick k pairs of I1 and j1 and I2 and j2 all the ways to ik and jk. So we need to pick exactly k pairs. We cannot pick anything less than that or more than that. So we need to start from I1, and I1 must less than I2 and I2 must less than I3. And the matching pair for J1 is going to be the same. J1 must be less than J2, J2 must be less than J3. So that basically means we cannot reuse the same I or J over and over again. After choosing that pair, we can do an operation which is nums1I times nums2j. And after picking k pairs, we need to get the sum of them. And then we need to select the maximal achievable total score we can get from such selection. So let's take a look at this example. Nums1 is 132, nums2 is 451, and k equals 2, and the answer is 22. Why? Because first we're going to pick I1 and j1 is this just 3 times 4, which gives us 12, and then second we just pick this 2 times 5, which gives us 10, so 12 plus 10 is 22, and we already picked exactly 2 pairs, so we just return there. So the constraint here is pretty lenient, it's just 100. So yeah, this problem is surprisingly easy as a hard problem, but yeah, we'll see what can we actually solve the problem. So as usual, when we think about a problem like this, it's beneficial for us to start recursively instead of going directly to DP. So let's think about recursion. Ij remain. So let's just assume this is the max score we can achieve. We can get, or we can obtain maybe. We can obtain if we consider just nums I all the way to n-1 and nums j all the way to n-1, and and we have remain to pick. And we have remain to pick remain pairs. We still have remain pairs to pick from. So if we define our DFS like this, our final answer is just DFS 0, 0, and k, right? Because you start from 0, and then you also for the nums1, and you also start from 0 for the nums2, and we also have to pick k of them. So this is the final answer that we want. Let's think about the recursion step. So let's think about the fs I j remain again. So what are some base case? Okay, base case. So base case, let's say if I reaches the end or j reaches the end. So what does that mean? So if it reaches the end, there's no pair we can make, right? So it's just not possible. Or because we have in the problem description, we are told that we must pick exactly k pairs. So if we already reach k, so that means remain equals 0 because we start from k and then we go all the way back down to 0. So you already reached 0, and this is also one of our base case. So in this case, what happened? Because if we reach the last element, over the last element, there's no element for nums1 to pick, and it should be here. And then if that's the case, we just return. We need to check if remains equals 0. So it has to be remain 0. If it is not, but we also reaches the point that we cannot pick anything, we just we just need to return negative infinity. So we basically never want to choose that. We don't pick 0 here, because in some of the example, input can be negative. So 0 is larger than negative, so it should actually give us a wrong result. So we have to put negative infinity here. So otherwise, sorry, it should be the other way around, right? So it should be the other way around. Okay. So if you reaches k pair and you have nothing to pick from, it's just good, it's just 0. Otherwise, we just put negative infinity, because the main criteria here is to have pick k pairs. Okay. So let's move on to the non-base case here. So the result, at first we can ignore nums 1 index or nums 2 index, right? So if we ignore nums 1 index, is basically saying we don't want to match I to anyone. We just do I plus 1 here in J, and then remain, of course, it doesn't change that. And then DFS, or we can ignore the nums 2J indexed. Basically, we don't want to match this nums 2J to anyone. So in other words, this is just I and J plus 1, and then remain will stay at the same. And these are the two possibilities. Another possibility is that we do the matching. Okay, do the matching. So do the matching, what does that mean? So it is just nums 1 times, nums 1I times nums 2J, and then plus this one, right? So because we used I and J, we cannot reuse them, so we have no choice but to I plus 1 and J plus 1. Because we've already packed this, and then we have to remain minus 1 as well. And then we just return result. That will be our recursive call. Main body. Actually, is surprisingly simple, again, for a hard problem. But yeah, apparently you can do some memorization or iterative DP here for implementation, and I will talk about that a little later on the actual implementation part. But that's like the full solution. Yeah, okay, that's all for it for now. Let's move on. I'm gonna initialize the dimension, n equals to nums1 dot size, and then m equals to nums2 dot size. And we also need to set up an infinity, just for setting something, like for example, in some cases we need to return that is impossible. We cannot return 0 as we discussed, because something can be negative, so that we need to somehow know our custom infinity. I just set it as 10 to the power of 18. And then let me just go back and copy our previous reasoning on the DFS. So as you can see, we have 3 dimensions. This one is for the index for nums1, this one is for the index for nums2, and this one is for k. Therefore, we need to create a 3D DP array in order to resolve this. So factor, 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 and the answer is long here. Closed, 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 and then we call it DP. And the first one will have n plus one dimension, and the second one will be a 2D array, long, and it will have an n plus 1 dimension. And the third one is just a normal normal 1D array, which will be k plus 1. And yeah. So the next step is to, because we have 3 parameter, right? We know that we're gonna have a 3 nested for loop. So one is for I, one is for j, one is for remain. So we don't care about the order first, as usual. We're gonna determine the order after seeing how the DFS or how the DP are referenced. So let us just copy this whole thing, this recursive call, into this most inner loop body. So first we can see this one reaching the boundary case. We just change it from just directly return to setting up our current value, I, j, remain equals to this one, because we returned previously, and now we just need to continue. So it's kind of simulate the return syntax. And also this infinity, I use lowercase instead of uppercase. And otherwise, we will do this result. We will initialize this result. Let me change to C++ syntax. So this DFS, we just change DFS to DP because they are referencing the same thing. Here, just change this as well. And then we consider the matching. So the matching is just picking I and j and then move the index for both I and j, and then because we picked this one and we have to, for the matching remain, we have to do the remain -1. So let me change from DFS to DP again. DP j. So finally this return, again, we change any return to DFS, to DP I j remain. So just like that. So you just change our recursive call to DP. So you need to think about how can we design the order. So as you can see, we always reference I plus 1 or j plus 1. So how can we make sure that I plus 1 and j plus 1 is always ready when we are considering I? So the answer is we just loop from the very end. I plus plus, I minus minus, and then j equals to m, j greater or equal to 0, j minus minus, and this remain will be 0, remain can go up to k, remain plus plus. Okay. So at the end, we let me go back to the reasoning. At the end, we kind of set the final answer is this one. Let us just copy that. Sorry, let me just copy that here. So this one we just need to, change it to DP. DP and we're done. Let me quickly skim if there's anything missing. Yeah, so this result has to be long. Right, this seems fine to me. Let me try to run that on LeetCode. Let me run. Okay, sample test case passed. Let me try to submit. Okay, because it's overflow, so this nums1i and nums2j can somehow overflow, so we have to cast the nums_i first. Let me run again. Let me try to submit. Yeah, accepted. Let me go back to here. So the time complexity is just, you see we have 3 nested loop. It's pretty easy to calculate. So inside just O1, we do some O1 calculation. Let me change it back to long. Okay, so this is On. So as a result, it should be time, should be On times M times K, and then spaced similarly N times M times K. Yeah, that's pretty much all. Again, for hard problem, it is a simple one, surprisingly, and I feel like LeetCode has been giving out a lot of DFS question over and over again for hard problems. I hope they will have something new next time. Yeah, it's just some of my fault. Thanks for watching again, and I will see you next time. Bye.